This cool piece of apparatus is called a gas syringe, and it collects gas. And not only does it collect gas, but it can tell us exactly what volume of gas it's collected as well. They're quite expensive, these gas syringes, so you don't see them in many places, but we're lucky enough to have a few. And we're going to use them to try to work out the effect of adding a catalyst to a chemical called hydrogen peroxide on the time it takes to collect 60 centimeters cubed of oxygen gas from this reaction. So I've got a measuring cylinder here with 25 centimeters cubed of 6% hydrogen peroxide solution, and I'm going to put it into this conical flask, sidearm flask, just here. And when I do, we're going to see how long it takes using this stop clock to collect 60 centimeters cubed of gas. Are we ready? I'm going to have to multitask here. In there, add the bung, start the stopwatch, and 60 centimeters. This could take a while. Why not come back a little bit later? Okay, 15 minutes and 51 seconds into the reaction, and I can tell you that we have collected absolutely nothing. No oxygen gas has been released from this whatsoever. What is going on? Well, the fact of the matter is, hydrogen peroxide on its own is incredibly unreactive. And yet, this stuff is rocket fuel. We use this stuff to get into space. So how on earth can we generate the sort of energy and the sort of gases needed to do that if this reaction is so very, very slow? It is reacting, it's just not producing anything in the time that we have available. Perhaps I can think of something to speed it up a little. And would you believe it? I think I've found the very thing. Some manganese powder. Just manganese metal, that's all, ground down. It's a rather boring looking grey powder. But if I add a little bit of manganese to this, just a tiny bit, perhaps we can speed things up a little. Oh well, there we go. You can see the bubbling already taking place. I'll just give a quick swoosh. And if I go over here, already you can see that gas is being collected. Now I only needed to put a very small amount of manganese powder in there because the manganese is not doing a chemical reaction with the hydrogen peroxide as such, it's acting as a catalyst. That is something that provides a different, lower energy route for a chemical reaction to take place. And that is causing the hydrogen peroxide to break down into water and oxygen. And yet the manganese itself isn't being used up. Instead, the particles of manganese help speed up the reaction of one particle of hydrogen peroxide. Then, once that goes, it provides a space for another particle of hydrogen peroxide to react. So I could have used an even smaller mass of that manganese to this, and yet my reaction would still be happening. And that, I'm sure you'll agree, is not a bad rate of reaction for this. I said we'd see if we can collect 60 centimeters cubed of oxygen gas. We're getting there. Okay. The fizzing is starting to slow down a little bit, but that's not to do with anything with the manganese. It's just that the available hydrogen peroxide has already mostly reacted. Don't forget, it's only a fairly low concentration of hydrogen peroxide. And yet, here we are about to collect 60 centimeters cubed. There we go. So, catalysts. They are chemicals that speed up the rate of a chemical reaction, and yet they themselves are not used up. They could be used time and time and time again, and that makes them really, really useful in industry, where we want to make chemical reactions happen as quickly as possible, as cheaply as possible.